Hello student, in our today's lecture we are going to talk about the oxo acids of phosphorus and the resonance structures of oxides of nitrogen. So first of all we start our sessions with the oxides of nitrogen. Oxides of nitrogen. First is N2O. It is called nitrogen 1 oxide, having a resonance structure like this: nitrogen, nitrogen, oxygen. Nitrogen is group number 15 element having a valence electron 1, 2, 3, 4 and 5. Suppose this nitrogen gain one more electron, so it consists negative charge, while this nitrogen consists 1, 2, 3, 4 electron. It means one less electron, that's why it gain positive charge. Oxygen 1, 2, 3, 4, 5 and 6. Suppose if this negative charge, that is a shift toward this double bond, and this double bond shift toward this oxygen, then the resonating structure is obtained like this: nitrogen, double bond convert to triple bond, and this double bond gets converted to single bond. This nitrogen possesses 1, 2, 3, 4, 5 electron. The nitrogen which is remain at the center point 1, 2, 3 and 4, so it consists positive charge, while this oxygen 1, 2, 3, 4 and 5, 6 and 1 excess electron, so it consists negative charge. Second, in oxides of nitrogen, NO. NO is called nitrogen 2 oxide. Possess the structure like this: nitrogen 1, 2, 3, 4, 5, oxygen 1, 2, 3, 4, 5, 6. The resonance structure of this is obtained like this: nitrogen 1, 2, 3, 4 possess positive charge, oxygen 1, 2, 3, 4, 5, 6, 7, one excess electron possess negative charge. Okay, now third one is NO2, is called nitrogen 4 oxide, having a structure like this: nitrogen, oxygen, oxygen. The nitrogen which is remain at the center point having a valence electron 1, 2, 3 and 4. So it having a one less electron, so it consists positive charge, while the oxygen it having 1, 2, 3, 4, 5 and 6 electron. This oxygen having 1, 2, 3, 4, 5 and 6, so it consists one more electron, that's why it possesses negative charge. The resonating structure. How this resonating structures of NO2 is possible? Only you have to shift the positions of the double bond from one side to the other side. So nitrogen, oxygen, oxygen. So the charge is also shift 1, 2, 3, 4, 5, 6 and one excess electron 7. So it consists negative charge, while this oxygen possess 6 electron. The nitrogen which is remain at the center point possess 1, 2, 3 and 4 electron. So it having a one less electron, that's why it consists positive charge. Okay, now the shape of this molecule. The shape of this molecule is planar. This is also planar. While this NO2 possess which type of the shape? So we can say that angular or bend shape. Angular or bend shape. Okay. Now the other oxides of nitrogen. Student, this topic is very important. You have to remember the resonance structures of oxides of nitrogen. Fourth number, N2O3. N2O3 is called nitrogen 3 oxide, having a structure like this: nitrogen, oxygen, oxygen, and this is oxygen. Okay, now this oxygen having a 1, 2, 3, 4, 5, 6 electron. This oxygen 1, 2, 3, 4, 5, 6, 7 electrons. So it having a one more electron, that's why it possesses negative charge. This nitrogen 1, 2, 3, 4, it having a one less electron, that's why it possesses positive charge. While this nitrogen having this nitrogen and this oxygen, so this nitrogen and this oxygen having how many electrons? So first of all, this oxygen having a 1, 2, 3, 4, 5, 6 electron. This nitrogen 1, 2, 3, 4 and 5 electron. So this is the structure of N2O3 nitrogen 3 oxide, and it having a which type of the structure? So it possesses planar structure. Now fifth one is N2O4. N2O4 is called nitrogen 4 oxide, having a structure like this. First we have to draw the structure of NO2. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. One excess electron, so it gain negative charge. Here 1, 2, 3 and 4 electron. 1, 2, 3 and 4 electron. So it possesses positive charge. Okay. Now nitrogen, oxygen and oxygen. So again here positive charge 1, 2, 3, 4, 5, 6 and 7. So it possesses negative charge. Here 1, 2, 3, 4, 5, 6. Okay. Now the resonating structure of this N2O4, dinitrogen tetroxide. So you only have to shift the positions of double bond. So here the resonance structure of this is obtained like this: oxygen, oxygen. This oxygen possesses negative charge, nitrogen possesses positive charge. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 and 7. Okay. 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5 and 6. Done. Resonating structure of this N2O3. So as I said, you only have to shift the positions of double bond. This nitrogen possesses positive charge while this oxygen possesses negative charge. 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5. 1 2 3 4 5 6. Okay, so this is oxides of the nitrogen. Now the one oxide of nitrogen is pending is N2O5. So student, N2O5 is called nitrogen 5 oxide. Is called nitrogen 5 oxide, having a structure like this: nitrogen, oxygen, nitrogen, oxygen, 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 oxygen. Oxygen possesses 1 2 3 4 5 6 7 electrons. So here the negative charges generate. Same here, 1 2 3 4 5 6 7. So the negative charges generate 1 2 3 4 positive charge. On this nitrogen again positive charge. Why? Because 1 2 3 4 it possesses one less electron, that's why. Oxygen present at the center point possesses 6 valence electron. Here this oxygen also possesses 6 valence electron. Oxygen 6 electron. Then, and the resonating structure of this, you student remember, you only have to shift the positions of double bond shifted to the single bond and single bond shift to double bond, having a structure. Which type of the structure? So it possesses planar structure. That possesses planar structure. Nitrogen, double bond, single bond, 1 2 3 4 5 6. Oxygen 1 2 3 4 5 6 7. So this possesses negative charge. The rest whole formations remain as it is. One, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. This nitrogen possesses positive charge. So this is oxides of nitrogen, student, and it is very important. Okay. Now student, we are going to study about the oxo acids of phosphorus. So the oxo acids of phosphorus, first of all, what is the meaning of oxo acids? So the simple meaning of the oxo acid is the compound which having OH group and indicate acidic property is called oxo acid. So in oxo acids of the phosphorus, first of all we studied about the H3PO2 is called hypophosphorus acid. Is called a hypophosphorus acid, or it is also known as a phosphinic acid. Okay, the structure of this H3PO2 is like this. H3, it means here we have to arrange 3 hydrogen and 2 oxygen. 1 2 3 hydrogen, 2 oxygen, 1 phosphorus. It having how many P double bond O? So 1 P double bond O is present, 2 pH bonds are present, and 1 POH bond is present. Okay. Now what is the oxidation number of this phosphorus? We know that this oxygen having a -2 charge, hydrogen +1 and hydroxide ion -1. So it having this phosphorus having a oxidation number plus 1. Okay, what is the basicity of this hypophosphorus acid? The basicity of the hypophosphorus acid, basicity, it means this hypophosphorus acid is able to donate one H plus ion. The H plus ion which is directly attached with the phosphorus, that is going to combine with the phosphorus through very strong bond. So it is not easy to break this bond. So the only one hydrogen is replaceable. So it's indicate its basicity. So basicity of this hypophosphorus acid is plus 1. Okay. Reaction. How this is obtained? So this is obtained by reactions of white phosphorus with alkali. So it is obtained by the white phosphorus on its reactions with alkali. Okay, now student, the next one is H3PO3 is called orthophosphorus acid. Orthophosphorus acid. This orthophosphorus acid having a structure like this: phosphorus that is going to attach with how many hydrogen? 3. So 1, 2, 3, H3PO3. It having how many PO bonds? So 1 P double bond O, 2 POH bond, and 1 PH bond is present. Oxidation number of this phosphorus: oxygen -2, +1, -1, -1. So -2, -2, -4, +1, -3 goes on opposite side. The oxidation number of phosphorus is +3. Basicity is +2. How it is obtained? So it is obtained by the reactions of H2O. So H2O on its reactions with P2O3. So H2O on its reactions with P2O3. This orthophosphorus acid is obtained. Now the next one is the next one is pyrophosphorus acid. Molecular formula H4P2O5. H4P2O5 is the molecular formula of pyrophosphorus acid, having a structure like this: phosphorus, oxygen, phosphorus, okay. Now OH, OH, H, H. So H4P2O5. Okay, it having how many P double bond O? So 2 P double bond O are present. Okay, 2 POH bonds are present and 2 PH bonds are present. Okay, here the oxidation number of phosphorus. So the oxidation state of the phosphorus H4P2O5. In this H4P2O5, the oxidation number of the phosphorus: oxygen having a -2 charge, minus 2 into 5 minus 10 plus 4 plus 6 by 2, so it having a oxidation number plus 3. Okay, how it is obtained? So it is obtained by the reactions of H3PO3 with PCl3. H3PO3 with PCl3. Okay. After this pyrophosphorus acid, one more oxo acids of phosphorus is called hypophosphoric acid, and the formula of the hypophosphoric acid is H4P2O6, having a structure like this. H4P2O6. Okay, how many bonds? P double bond O are present? 2. How many POH bonds are present? So 2 POH bond. How many? 4 POH. Each phosphorus consists 2 POH. That's why 4 POH. Okay, and 1 PP bond is present. Okay, students, oxidation state of phosphorus. So in this oxidation state of the phosphorus, minus 12 plus 4, minus 12 plus 4 minus 8 हो जाएंगे, और minus 8 divided by 2 plus 4 goes on opposite side. That's why minus 4 gets converted to plus 4. Okay, reaction. So this is obtained by red phosphorus on its reactions with alkali. Now orthophosphoric acid. Now student, orthophosphoric acid having a molecular formula H3PO4. Structure is like this, H3PO4. It possesses how many POH bonds? So 3 POH bonds are present. How many PO bonds are present? 1 PO bond is present. Okay. Now student, this type of the H3PO4, what is the oxidation state of phosphorus? So the oxidation state of the phosphorus, minus 2, minus 1, minus 1, minus 1. The oxidation state of this phosphorus is plus 5. How this orthophosphoric acid is obtained? So this orthophosphoric acid is obtained by the reactions of P4O10 with water. P4O10 with water. Okay. Now the next one is pyrophosphoric acid, having a formula H4P2O7. The structure of H4P2O7 is like this. H4, 1, 2, 3, 4, H4P2O7. The oxidation state of phosphorus in H4P2O7 is +5. How it is obtained? So it is obtained by the reactions of, when we hit by heating of phosphoric acid. This pyrophosphoric acid is obtained by heating of phosphoric acid. This pyrophosphoric acid is obtained. Okay, students, it having a how many? Here the bonds. It having a how many PO bond is present? Only one. It having a how many P double bond O are present? So it having a 2P double bond O. And it having a how many POH bonds? 4 POH bonds are present. And the last one is called metaphosphoric acid. Metaphosphoric acid, or it is also known as a cyclotrimetaphosphoриc acid. It having a molecular formula HPO3N or HPO3 thrice. Structural formula The structural formula of HPO3 thrice is like this. Okay, so first of all, it having how many P double bond O? So for HPO3 thrice, it having a 3 P double bond O are present. 3 POH bonds are present, and 1, 2 and 3. So 3 POP bonds are present. The oxidation state, here the oxidation state of the phosphorus is, the oxidation state of this phosphorus is +5. And how it is obtained? So it is obtained by the reactions of H3PO3. So it is obtained by the reactions of H3PO3 with Br2. So this is oxo acids of the phosphorus. Thank you for watching, students.